Okay, so this is the lesson for your atoms and molecules, right? I think this is a Sec 1 topic. Okay, so let's look at this. I will not just be going through the answers, I'll go through the concepts behind. So make sure you write down those things that I write up here. Okay, element X has 33 nucleons, 16 protons. What is the charge of protons? Protons is positive. What other subatomic particles are there? Why are they called subatomic? Because after atom, they are the sub one. They are the ones that form the atoms. So we have protons. What is their charge? +1. Who else do we have? Oh, okay, sorry, I wrote electrons already. Electrons is -1. Then what else do we have? What is the charge? 0. Yes? Now, what is the mass of the proton? Sorry, I shouldn't ask that. Does proton have mass? Yes. Does electron have mass? The mass is, I think they have this value, right? 1/1836, right?
Yeah, 1/1836.
So if the mass of proton is 1, let's say I just give it 1 unit. The mass of electron is 1/1836. So if I give you $1, how would you feel? Hey, okay, I'm $1 richer. But now if I say I give you 1/1836, how would you feel? You'll be like, nah, I don't even want to take it. Okay? So this mass of electron is very, very small. Okay, how about neutrons? Also have mass. I give it like maybe 1 unit. Right? So equivalent, neutron also 1 unit of mass. Okay? Yeah, protons and neutrons have the same mass. So far, okay? So protons are positive. Who are some of the positive people that you know? Mr. Lee, very positive. So every day I wake up, I will say, hey, I'm going to go to work. Yes, I'm going to make a difference in my students' life. Okay, so I'm very positive. So I'll be very successful. When I'm very successful, I can buy a big house. Alright, so where do I stay? I stay in a big house. So this is what protons do. They stay in a big house called the nucleus. So the protons or the positive people, they can afford to stay in a big house. Okay? How about neutrons? They are neutral people. So one day, I saw my ex-classmate. I said, hey, this guy quite neutral towards me. So I said, hey, you want to come to my house and stay? So the neutrons, they will stay with me. They will stay with me. Okay? Then now protons, because I can stay in the house, I got money, I buy food. When I buy food to eat, what happens to my mass? My mass become very big, right? You see all those quite rich, okay, the rich bosses, their size quite big, right? So they have mass. So the positive people, they have money, they can buy food, they have mass, they eat. How about neutrons? They stay with the proton. My friend, I invited him to stay at my place. If I eat, he will eat also. Does neutron then have mass? Yes. So this is just my story to help you understand. Okay. So you all understand proton and neutron? How about electron? Are they positive people? Negative, they wake up, they say, if I go to work today, I'm going to get fired. Remember, I work as a Grab, but then later I get knock down. So they are very negative. So will they have money? Where will they stay? They won't stay in the house. They will stay outside. They will stay outside. So electrons will stay outside. They will not be able to stay in my house. I don't want them in my house. They are negative people. Correct? Will they have money to buy food? No. So their mass very little. So their mass is very little. So okay, my story later for second part. Yeah. Huh? This is the official mass. Okay, so if proton's mass is 1 unit, neutron's mass is 1 unit, electron mass is 1 over 1836 units. That's very, very small. And that is how they are surviving. They don't have money, they are negative people. But protons are positive, successful, rich, they can stay in the house.
Yeah. Does the electrons stay inside the cell or outside?
Okay, so all these, they are in the atom. They are in the atom, but they don't stay inside the nucleus. They stay in what we call electron shell. Right, you all heard that right? Before heard this term before. So electron shell. So later my story got a second part. Okay? Yes. So we come to this. Can you all give me some example of an atom? Okay, how about? Have you all heard this guy? Na is what? Na is sodium. Where can you get this from? If I give you Na, where can you get your? You can get it from the periodic table. Right, you can get it from periodic table. Will periodic table be given in every exam? Yes. So you can check, oh, this Na stands for sodium. What is the number above it in the periodic table? If I'm not wrong, it's 11 and 23. What is this number 11? Do you all still remember? Yes, it is called the proton or atomic number. Okay? I hope when I write this, you remember what it is. 281? How do I get 281? What is this 281 for? It is called the electronic configuration. You need to know this. But why is 11 broken down into 2, 8, and 1? Because of the shell, right? So, you all want to hear a lame story? Okay, 281, what do Chinese like? Which number do Chinese like?
7.
Chinese don't like 4.
7.
Because sounds like God. They like 2. Right? Because 2 is like a number. Okay? So they like the number 2. What else do they like? They like the number 8. Because 8 in Hokkien sounds like what? What means prosperity? What means prosperity? So, okay. This is just my own story. So they like the number 2 and 8. So this is in the first shell. This is in the first shell. This is my sodium nucleus. Who is staying in the nucleus? Who stays in the nucleus? Protons and neutrons. Who is staying outside? Electrons. They are having 2, 8, and 1. Now, some of you may be wondering, this is proton number. Why am I talking about electrons? Because this proton number is equal to the number of electrons. Which means to say everything in the periodic table, it is an element of of that atom. An atom must be neutral. The number of protons must be equal to number of electrons. You have this. Now, simpan. So as I was saying, elements of the atom in the periodic table, they are all neutral. All neutral. That means your electron must be equal to number of protons. So if I show you proton number, you will straight away know the number of electrons. Okay? So now I have 11 electrons, I have 11 protons because they are neutral. 11 plus equals to 11 minus. So far, are we okay? Then we now need to know how to split into 2, 8, 1. Then you think of this same story. The first shell can only hold up to 2. Why 2? Because Chinese like the number 2. Okay? They don't like number 4. But never mind. Because it sounds like death. So I have 2. Second shell, bigger. Second shell is bigger. So how many can I accommodate? I can accommodate 8. Why 8? Because Chinese side is the number 8. Okay? So just a lame story to help you all remember. Then the last shell, but left only 1 electron. So this is how we represent the electronic configuration of sodium. This is how you need to draw, if they say draw an atom of sodium. This is in set 1, remember? Yes. Okay, and did you all learn about formation of ions? No. Never. So it's just like that. So you all know that it will become Na plus. Do you all learn this? Learn or didn't learn? Because last year I didn't teach you all. The plus 1 and minus 1. You all learn all. Okay. So can I tell you my second part of the story? So far, any questions? Okay, so you must know electronic configuration. You must know how to draw, right? And you must know first shell maximum 2, second shell maximum 8. Okay. Okay. From calcium 2A2. Yes. Okay, very good. So now I'll explain why this becomes Na plus. Can somebody tell me? Can be best is here lah. Sorry, my this one not very accurate, right? It's either on top, left, right, or bottom lah. Don't just any random one. Okay? Can. Yeah. Group 18, can you give me an example? Can you check your periodic table? Who is in group 18? 18. Argon, What's the number on top? 18. 18, What's the number below? 99.9. Oh, okay. So about 40, So 18 and 40, I haven't go to the bottom number yet. Top number, when you see this, what does this 18 mean? What number? Atomic number. So what does the atomic number tell you? I will have 18 protons. I will have how many electrons? 18. Okay, so this is what the number tells us. Now, if you know the number of protons and electrons, can you now tell me what is the electronic configuration? No, the electronic configuration. 2, 8, 8. Then maybe you just do a calculation. 2 plus 8 plus 8 is 18. So it fits the number. Okay? So if the third shell, which is also called the valence shell, third shell is valence shell. If the third shell or valence shell is having 8 electrons, it is full already. What number do Chinese like?
8.
8, ah? So they are very happy already. So if I draw my argon, I draw the last shell, ah. I got 1, 2, 3, 4, 5, 6, 7, 8. So this is a stable electronic configuration. The last shell is 8, contains 8 electrons. It is stable. So that's why argon, group 18, they are called the noble gas. They don't react. They are forever alone. Argon will just stay by himself. He sees another atom, he will just stay by himself. Once you receive 288, your last shell having 8, right? You are stable electronic configuration. Understand? But if you look at sodium, sodium just now what was the electronic configuration? 281. Okay? The last shell how many? 1. Stable or not stable? Unstable. So they all want to become stable. Correct? Who wants to be unstable here? Anyone? Yeah? Do I look stable? Sometimes I look quite unstable. Right? So I try to be stable. So now we go back to to sodium. We go back to sodium. The last shell is 1. So how can sodium be stable like argon? You look at argon, wow, very stable guy. I wish to be like him. So sodium take in 7 electrons or lose 1 electron. Why take in 7? If I really want to force him to take in 7, why take in 7? Because 7 plus 1 will be 8. Right? But I will take in 7. Will it be easier if I lose 1? Yes. So he will lose 1. And remember, electrons, are they the successful people? They are like homeless people, right? If you go to the street now, and you take a homeless people, homeless guy, will anyone do this? No one, right? No one will like care about the homeless people, right? Can you go inside this house and take the successful people? Yes. Can I'm sure they will have what? Security guard, they will have gates. So that's why only electrons will be taken. But number of photons will stay the same. That's my second part. Yes. Yes. Vertical is called group. Horizontal is periodic table. Yes. When you take in one, okay, let's come to this. So you understand argon? Why he don't do any reaction? Because it's really very stable. Right? So let's look at sodium. The whole group 18 is stable. We have neon. Neon give me what's the number? 2, 4, right? So what is the electronic configuration? Electronic configuration is just 2. Then if we draw so is neon stable? Oh, neon is 10 and 20. Oh, helium, sorry. Huh? 2 and 4. Helium, sorry. Let's do helium. Electronic configuration is 2. Why 2? How many photons? 2. How many electrons? 2. Stable or not stable? Okay, that's how we say we want 8, right? But this is only the first shell. First shell we can allow 2. Because you want to squeeze it 8, cannot, too small already. The shell too small. Right? So we have 2. So helium stable. Helium stable. Group 18, the vertical column is stable. Okay. Then just now somebody say neon, right? Let's do neon also. Neon, what is the number on top? 10. Bottom is 20. So around 20 lah. Okay. So for neon, what is the electronic configuration? 2.8, right? Stable or not stable? First shell. Second shell, how many? 8. Second shell, 8. Stable. So all of them are stable. And all of them would want to be stable like the group meeting. That is the whole purpose. If they don't do this, if they don't give electrons and electron, nothing will happen. There will be no chemical reaction. Okay? So this guy sodium, there is one electron outside. One electron outside. So we all agree that it's easier to give away one electron rather than take in 7. Yes, rather than to achieve stable electronic configuration like the noble gas. Which is in group 18. Do you all agree with this statement? The sodium, I have one valence electron in the outer shell. It is easier to give away one electron rather than go and take 7 of the people to make up a stable electronic configuration. So they will give away electrons. They give. Why do they give? They want to be like a noble gas. Noble gas are your argon, neon, and helium. Right, they are already very stable. They don't react at all. So let us see what happens to the sodium after he give away. So he will look like this now. Nothing much has changed because nobody actually noticed that the negative guy was removed. Right? Nothing much has changed. Just that this third shell, the last guy was missing. But do you all even care about the guy who like sleeps under the bridge? So what? Right. Now, how many protons are there inside the nucleus? What's the atomic number? Let's see. 11. How many electrons do we have? How many electrons do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Number of protons more than electron, right? So overall, how many more? 11 versus 10, right? Positive 11 versus negative 10, right? So what's the result?
1.
The result is this thing now becomes positive 1. Was this what you have done in Sec 1? You all know this in Sec 1? Because it lost electrons. And why those electrons? Because electrons stay outside the house. They are very easy to be removed. Right? Not like those big balls stay in the house. So I remove electrons. Now I have lesser number of electrons. I have more protons. So more positive versus lesser negative. So the final result is plus 1. Because every electron that I remove, my charge had a positive 1. Simple that? Can? Cannot? So we did a positive 1. Should we try a negative 1? What is the most common? Sodium chloride, right? Should we do chlorine? You all want to try yourself? Chlorine now, I will use another color. Chlorine, what is the number on top? Below is 35. I haven't covered what is the bottom number, but we will do so very soon. So what's the electronic configuration?
287. Yes, 287. That means my outermost shell 8 1 2 3 4 5 6 7. Yes, stable or not stable?
So 287 so stable or not stable? Not stable. How to become stable? Plus one more. Who will give? Don't worry, there are a lot of people who will give. Remember sodium is more than happy to give. Right? Because sodium 281 when he want the last single electron, they will be more than happy to give. And some people will be more than happy to take because all they want is to become stable. Right? So,
Sorry, by right I should use circle and cross. But then I will use color, can?
this will get a charge of -1. So now in sodium cis chlorine, I give you 1, you take it my 1, oh, +1 and -1, they are like opposites. Then they will attract. Then they will become your sodium chloride. Okay about this? That's how chemical reactions happen.
Okay, let's do one more example very quickly. Oxygen. Oxygen 8 and 16. But some students will say,
oh, 8 wow, very stable. But you must do your electronic
configuration. 2.6. So how many electrons does it need? 2. So what will be the charge of oxygen? -2. And this is what you call your oxide. Right? This is your oxide. Your chlorine becomes chloride.
So those who are negative, they will have this ending I. Okay?
We do one more sulfur very quickly. Sulfur, what is the number on top? 7, right? 7, 14. So this will become 2.5. Yes? Need how many electrons? Plus 3 negative. So sulfur will become -3 sulfide. Yes? Sorry, I should represent it in 3 minus. So this sulfur will become, sorry. This sulfur will become sulfide. Okay, it's just their naming. You cannot call it sulfur anymore because it took in 3 electrons, something has changed. So it's called sulfide. Okay, any part you need me to clarify or need me to do just one more example? No need, okay, So you must know your electronic configuration. And that comes from your proton number. Now we do the bottom number. We use sulfur, 7 and 14. How many protons? 7 protons, 7 electrons. Then the bottom number is called mass number. What else? Your periodic table, what does it say? Relative atomic mass. What is this number? This number is the number of mass. Who have mass? Neutrons and protons. So this is the number of neutrons because they have mass plus protons. So if I have 7 protons, total I have 14 protons and neutrons. How many neutrons does this have?
7.
It's just a coincidence that they are equal. Some are not the same. Look at sodium. 11 and 23. Sodium. 11 and 23. How many neutrons? 23 minus 11 equals to 12. So 12 neutrons. Because I have 11 protons. This number is the number of protons and neutrons. So if I take this number, subtract by a smaller number, I will get the number of neutrons. So with this, we can finally go to our first question. Okay? It has 33 neutrons. 33 neutrons is just a mass number. Mass number. So how many protons does it have? How many electrons? How many neutrons? 33 minus 16 equals to 17. So the answer is A. Okay? All this just for one MCQ. But this is important. When you go to Sec 3 chemistry, this is important. Luckily the second MCQ we can also do. Which one? Where do I get this? So beryllium, what is the number on top? What is the number below? 9, about 9, So 4 means 4 protons, 4 electrons. Then 9 means 9 minus 4 gives me my 5 neutrons. This is where I get my P and E. This is how I get my N. So just look for the correct one. Answer is B. Simple. By the way, is beryllium stable? What's the electronic configuration? 2.2. This one okay, but this one, how many does it need? Will it take in 6 or give out 2? Give out 2. So it will give out 2. Hey, you give out 2, easier ma. If not, you have to go and get 6 Right? Guys, it's like playing a game. I say now we must form a group of 8 Form a group of 8 That means I must have 8 people inside So is it easier to get these 2 out or easier to get 6 more in? These 2 go out. Then leaving a shell stable electron. Yes. 2, 4, I will leave it to your upper side figure. Okay? Yeah, 2, 4 not tested. 2, 4 not tested. It's only the 1, 2, 3 and the 5, 6, 7. 1, 2, 3, will they give or take? They will give. 5, 6, 7, they will take. So 1, 2, 3, which group are they in? Group 1, Group 2, and Group 3. Don't believe me, you look at your periodic table. You all can do mental sum very quickly, right? Look at Group 1. Who is in Group 1? Yeah, I don't have periodic table. Who is the first one? We have sodium, Na and K, right? K is how much? 19, 2, 8, 8, 1. Correct? Sodium is 2, 8, 1. They all end with 1. Group 1. Group 2, who are they? 2.2. Magnesium, how much is it? 2, 8, 2. They all end with 2. So they are in group 2. So that is the secret of your periodic table. They arrange nicely for you. So if I look at group 1, they should all end with 1 valence. If I look at group 2, they should all end with valence electron of 2. If I look at group 5, they should all end with 5, 5, 5. Get it? So actually, if you know this secret, you don't even need to know this, right? I will know how many valence. Okay? Can which of the following has the most number of types of electrons? Elements. Number of types. So answer is D. D is Mg, S, and O. But which one has the most number of atoms? Will be B. I have 6C and 12H. Okay, so total I have 18. Now, which one has the most mass? Which one is the most massive? Heavy. Which one? You need to add up the atomic mass plus atomic mass. I need to add up 6 times of carbon's atomic mass and 12 times of hydrogen atomic mass. Because I'm dealing with the mass. I need to see their mass number. Okay? So you all can go and add up. We only did question 3. Don't go yet. No. You still have 2 more holiday homework. Now I'm giving you all more worksheet. No. You can don't do.
I do all 3 already. I never submit now.
Yeah, I know you all did it, but you all should be doing it. Who is absent today?
Wait, now we take one more.
Okay. Who is absent today? Anyone absent today? I think already. Given ready, they say.
Wait, I never say.
Oh, then you take. Sorry, this one meant for my other class. I do already. Confirm. Okay, get down to it.
Yeah, but I'm trying to get it.
Hey, y'all can go for this lesson.
Thank you. So I find the other thing.
Well, you must make effort.
I try. I did your holiday homework. And I didn't do the rest. I only did yours, English, and